Immortality means eternal life and eternal existence. For ages, immortality has been the dream of many. Many people, one way or another, are looking for it. Some of us are in religious beliefs such as life after death or reincarnation, and some of us are in technology or science. As we have already explained, that can be phrased from the point of view of us humans, but from the point of view of the continuity of nature. The existence of death is much better than its absence. But despite this, some creatures that can be claimed to be immortal exist today. Bacteria from the simplest are technically immortal because they reproduce by cloning, and as long as one of these copies lives, the original bacterium itself can be considered alive. In fact, with the same logic, we can produce immortal cell lines such as HeLa cells in the laboratory. But it's possible to see similar stations in larger creatures. For example, we know that jellyfish of the genus Turritopsis, when they are old enough, are able to return themselves to their polyp, that is, offspring, versions, and start their life cycle anew. Similarly, we also know that flat forms continue to survive even as a result of splitting into 2, 3, and even dozens of pieces with a knife. They are able to make their own copies from each piece. But if we are going to beat that as humans, we need to do better than that. As humans, can we be immortal? Or how close are we to immortality thanks to our modern technology? Two components of immortality: genes and the environment. If we want immortality, we need to take advantage of two elements at the heart of biology: genes and the environment. First of all, let's start with the environment, because it is this component that people can most easily control. But because they don't do it, they can't maximize their lifespan. Extend life by dominating the environment. Today, our 100 years until the age of when we look at the lifestyle of living in a healthy way, a distinct pattern emerges. Most, they don't smoke, consume alcohol, or control it. They are not obese, have a strong and healthy social relationships, active and safe sexual life, and vegetables they eat, or are exercising in the fresh air, have a life. Cope with the stress or stress are good at embodying. For this reason, they are less likely to have fatal or life-shortening diseases such as blood pressure, heart diseases, cancer, diabetes than their peers. Therefore, they are also more likely to live long lives. We also know from historical data that optimizing the environment and the health and the hand works. For example, the average human lifespan in the 15th century was about 30-35 years, but this does not mean that 600 years ago everyone was dying at the age of 35, because many newborn babies were dying due to childhood diseases before they even reached the age of 5, and therefore they were also lowering the average life expectancy of society. Also, the life expectancy is usually given as a fixed number, but it's necessary to understand this expectation better. Take, for example, a child born in 1990 in America. The life expectancy of this child at the time of his birth was about 75 years. But this is far below the age at which many people died at that time, because the risk of a person dying as a child is much higher. For example, when the same child reaches the age of 25, his life expectancy increases from 75 to 82 years. Even if nothing changed in his country or life, at the age of 62 it increases to 86 years, and at the age of 70 to 88 years. In other words, the expected life expectancy increases constantly but gradually as you manage to survive. This is why, as the health and living standards of both children and adults have improved throughout history, the average life expectancy has increased. Of course, the increase is not equally everywhere. For example, women live longer than men, and citizens of rich countries live longer than those of poor countries. That is why we need to provide as accessible health care as possible for as many people as possible. It is like, just do this, do that, not by saying. We need to create environments that will reinforce them. We need to take into account human behavior and the fact that they can be changed by mechanisms such as nudging, exercise, healthy foods, medications to treat diseases, and doctors need to be both physically and economically accessible. It is necessary not to use violence against health workers, subject them the absurd performance criteria, put them on the target board of ridiculous reasons, and cause them to flee to country. But there is a limit to environment impact. If we also exercise until the morning, you can also live the most stressed life on earth. For example, you can't live for 300 years. Our genes set a limit on us. In fact, according to an article published in 2019, the natural lifespan of our genes provides us is about 38 years. Added to this year is the achievement of human civilization. Access to food, clean water, medicine, science, healthcare gradually increases this dual true. How far is it? The longest lived person who can be confirmed by official records that he lived to this day was the French Jeanne Calment, who lived 122 years and 164 days. Of course, if you look at the unconfirmed claims, you can find people who claim to live for hundreds of years. However, it's possible to determine the ages of individuals at a margin of 5 or 10 years by looking at X-ray scanning, dental structure, bone age, data such as miniature blood vessels in bones called osteons. To date, no one has been able to scientifically prove this uber-life claim. Extinct life by dominating genes, and that starts with getting to know the genes well. We know how big consequences even the slightest change in our genes, inherited up to by choosing the best ones from the alternatives that have been around for millions can have. It is possible to change these genes in many ways, but generally genetic engineering research focuses on three goals. The first is to develop a mechanism that prevents the shortening of the telomere regions of our chromosomes at each cell division. That is, to slint the cellular time bomb. Secondly, to find methods that will make it easier to eliminate mutations and other problematic genes that accumulate in our cells. Thirdly, to slow down and, if possible, even reverse the natural aging processes. All three of them are trained to minimize genetic damage. There are many genes that can help us on this path. For example, the SRT6 gene provides the recovery of proteins and enzymes used in DNA repair. The DF2 gene not only controls aging, but also strengthens the stress resistance and metabolism that we maintained above. Of course, the networks that these genes establish are also important. For example, if DF2 is activated together with another gene called DF16, they can change how hundreds of other genes are decided. And this results in extended lifespan in animal experiments. Certain mutant versions of genes such as APOE, FOXO3, and CETP are more common in long-lived people. But let's not list all the genes one by one here, because we should have maintained dozens of genes. In summary, there are not one or several genes common to everyone with longevity. Each of them has different genetic components, and the right combinations of them contribute to the longevity of people who live long. Therefore, we can say that immortality cannot be achieved with just a few mutations. Different combinations of these genes led to different results. That's why gene diagnostics and understanding what they do, what kind of genetic networks they are part of, are so important. Prolong life with modern medicines. Not only genetics, but also vaccines, drugs, and supplements can also be used to prolong life. For example, pistachios, grapes, red wine, and pomegranate in a molecule called resveratrol found in foods such as supplements. With a heavy fat diet, fat forms, yeast, and meat longer makes against it, also there are studies. Another is a molecule called nicotinamide monoclonate, that is NMN. In mice, resolved it. Nicotinamide adenine dinucleotide, that is the synthesis of NAD molecule, is increased by 15%. You may remember this molecule from molecules such as an NADPH in high school biology classes. It's a very basic molecule involved in cell metabolism, energy production, and DNA repair. It also ensures that your body can fight the diseases. Here, mice receiving supplements are becoming healthier and stronger. For example, they can run longer distances with less fatigue. Researchers continue to investigate the relationship of this with life expectancy. No magic molecule has yet been detected, but it may be possible to exceed our biological limits by including a wide range of molecular supplements in our diet, including antioxidants that slow down the free radicals that break down our cells. For example, the role of such fields as food engineering or even food design will be very great here. All these acids, even the vaccines we have developed, have allowed us to practically erase dozens of diseases from such to the date. Even as such a global scourge as the COVID-19 pandemic, vaccines extend the lives of those who have been vaccinated. Preventing the diseases before it happens is the biggest weapon on the road to immortality, and vaccines provide it. Of course, not only that, we need to fight against diseases and trauma in a holistic way, including the communication of cells with each other. What is happening in the digital space, the hormonal system, and epigenetics. It is also worth noting a very important detail that is often omitted here. Medicine has been developing methods that will make us healthier for centuries and has achieved tremendous success on this path. But to date, it has been advanced in medicine mainly on average characteristics. So, the focus is on such questions as how the body of an average person works, how it deteriorates, and how to treat it. Then, what was learned from this average was applied to everyone in much the same way. This has worked very well so far, but as we push the boundaries of health, we have begun to approach the boundaries of this method, and the problems created by biases in the progress have become obvious. For example, diseases such as menstrual pain problems that are specific to women are investigated much less frequently. Similarly, many medical statistics that still guide medical practice today are based on data collected on male subjects centuries ago. This demography does not reflect the current society. Here, we need to solve these problems both systematically and technologically. This post is not able to fit the need for systematic change. However, the development of technology to the immortality of the way a little more every day. It can be said that delayed. Used computers, progressive power, artificial intelligence, and medical hardware was not able to deal with the absence of the specific type of individual. But now we are entering a stage where technologies that will identify individual medical needs can give results that are superior to general methods. Soon, it will be possible to sequence our individual characteristics such as the genome in a few seconds. Think about it this way. 20 years ago, we sequenced the genome of one single human being for $3 billion by trading for 13 years. Now this period has decreased to a few days, and the price has decreased to $300. An artificial intelligence algorithm will be able to read this genome, identify the most likely individual risks, and notify physicians. Thus, although it is not an average medical intervention, a much more specific treatment path can be followed for that patent. Of course, these individual methods will also reflect the average and general procedures, but they will allow us to catch up with what the general producer has missed and maximize individual health. Here is an overview of all this, where we are about immortality, and the research that has been done. In summary, as you can see, if we somehow want immortality, we need to dominate aging, diseases, trauma, and the environment. We don't know if we'll see it. But one thing we do know, that some people who have lived in the past and are no longer among us have developed the science and technology that will make it possible for us to talk about them. And in our opinion, they have already become immortal just because of what they have added to science and humanity. Perhaps, in order to become immortal, it's not necessary that only the body lives. Perhaps the living of ideas and the works put forward is the kind of immortality that we cannot easily access. Maybe it's not necessary to look for immortality too far away. What is it about? Do not forget to subscribe and like it in the research description section that I use. Stay healthy.